Time to implement try. Here again is our concrete syntax for mo try, and we need to translate that into abstract syntax. So here's a try expression, which contains a body and a handler expression. And then we'll need to extend our parser to translate the surface syntax down into our try expression. We've got lots of experience extending the parser at this point, so let's move on to the interpreter. The first step in interpreting a try expression is to run the interpreter on the body expression. So we interpret the body, but we need to remember that handler. So we set up a new continuation, try k, and that has the handler expression and its environment attached. Next, inside continue, if we reach the try k case and we've got a value, that means that the body expression evaluated successfully. And so we can continue using that value. We don't need to use the handler because the body didn't raise an exception. So then where do we use the handler? That's back in our helper functions. Any place inside the interpreter where we were returning an error v, we now need to search for a try k in the continuation. We'll do the searching with a helper function. So this means that we need to change every place that there was return of an error v. Now call this helper escape and pass in both the error v that we plan to return and the current continuation. So escape will search through that continuation for any try handler. For example, if our continuation is for a plus k and our current value is an error v, then we need to fail because the plus k does not have any try handler on the inside, and we've just found an error value. If, on the other hand, our plus k is sitting inside of a try k, escape should find that try continuation and then interpret the handler expression. Finally, if our plus k is inside of a try k, which is also inside of another plus k, then error v should jump past the first plus, stop at the try handler, interpret that result, and then continue along. So we wind up with 2 plus 3 and int value 5 as the outcome. Here's the first half of the escape helper function. It takes in a continuation and a value, and it matches on the continuation. If it's a done k, then there's nothing to do, just return the value. If it's anything else that's not a try, then we call escape on the next continuation in the pipeline. We keep moving outward, outward, outward. If escape finds a try k, then it needs to interpret the handler. So grab that handler h, interpret it in its environment, and then make sure to carry along the next continuation so we don't forget about whatever the try was nested inside. And that's it. Success. We have implemented try catch for Mo.